This week we're moving away from probability back to the world of shape, to a topic which you will possibly have seen before, but there's absolutely no problem if you haven't seen it, and that's called Pythagoras. Now, Pythagoras was the name of a mathematician who lived a long time ago, and he was very interested in right-angled triangles. So everything that we do today, or this week in fact, is going to be to do with right-angled triangles. So I think that needs to be really clear in your notes that we're looking at right-angled triangles here. None of what we're about to do today works if you don't have a right angle. So remember, a right angle, 90 degrees, like a corner. Okay, so let's draw a right angle triangle. If I were you, I would draw this maybe kind of in the middle of your page, because we're going to be drawing some stuff around it. So we're going to have a right angle triangle. Doesn't matter how big, 1, 2, 3, 4, 5, 6, 7, 8. Doesn't matter how big. I've done an 8 and a 6, but it doesn't matter at all. So now Pythagoras, and I'm going to put a little right-angled thing there because we have to have a right-angled triangle. So what Pythagoras did was he looked at loads of triangles, and he tried to work out if there was a rule, a connection between the lengths of all the sides. So he looked at loads of triangles, and in the end he came up with probably one of the most famous equations in maths, and you'll probably have seen it or heard about it, called Pythagoras' theorem. But it's really simple. That's the wonderful thing about it. Okay, now for Pythagoras we're going to have 3 letters. We're going to have A, B and C. Little a, little b and little c. And the rule is going to be really simple, and we're going to have a really nice way of working it out. Okay, so let's do some labelling and talk about an example. So in our right angle triangle, we're always going to put the letter C on our picture first. And the C will always go opposite the right angle. That's where C always goes. And let's write that on him, in fact. So let's write that C always goes opposite the right angle. Okay, now C actually has a posh name. A very long word. C is what we call the hypotenuse. You don't need to know that, but it's possibly worth remembering, called the hypotenuse, and it's the longest side in a right-angled triangle. And the longest side is always opposite the right angle. And then we're also going to be using little a and little b. So I'm going to put an A there and a B there. Now it doesn't matter which way round you put those 2 labels. So let's write that on. So it doesn't matter which way round you write these. Doesn't matter where A and B go. I could have put my A there and my B there. It doesn't matter at all. Okay? Now, Pythagoras came up with, but I think probably the most famous equation in maths. Your parents possibly remember it from school, your grandparents even remember it. And what that is this. A squared plus B squared equals C squared. You might have seen that on posters, perhaps around the maths department. You might have heard it. And that is Pythagoras' theorem. Now, theorem just means something that he discovered and then he found out that it's always true. So A squared plus B squared equals C squared. Now, just remember, squared means times by itself. If you hadn't remembered that, that's worth writing down. C squared means C times C. And A squared means A times A. It's just a much quicker way for us to be able to write that. Okay? So let's have a look in practice what this means. And in order to do that, we're going to draw another picture. So can you draw me another triangle? Again, do it in the middle of your page. And this time I'm going to have a 3, I'm going to have a 4, and then I'm going to join them up like that. Okay, make your right angle, that's it. So a 3 and a 4, and then join up the other one. So what this means is that we can find the length of a side without using a ruler. So let's put a 3 on this side and a 4 on this side. And let's pretend that we don't have a ruler, so we can't measure this other side. And because it's going diagonally through the squares, I can't count how long it is either. Okay, so we're going to have to use this theorem, this rule, this a squared plus b squared equals c squared. We're going to have to use that in order to work out the missing side. So now a squared, that means that we need to make a square. Yeah, squared means times by itself, and that also has a really, really strong link with squares. Okay, so what we're going to think is we're going to think of this a squared and b squared and c squared. We're going to think of all of these as squares. Now we know that c is what we call the hypotenuse. C is the longest side, so we know that c is going to have a bigger square. Okay, so hear me out for now. So we're going to rewrite this equation using pictures. So I'm going to draw a square, and that's representing a squared. And I'm going to put my plus, and then I'm going to draw another square representing b squared. And then I've got my equals, and then I've got another square. I'm going to draw this a bit bigger. I know that c is going to be bigger because c is what we call the hypotenuse. So often in maths we try and use algebra. I think for Pythagoras it's a bit better if we actually use shapes like this. Right, I'm going to label my triangle now. Now think, where does c go? Well, c always goes opposite the right angle. And then a and b, it doesn't matter. I'm going to put a there and I'm going to put b there. Right, so remember this is my A triangle. And what is A? Well, A is 4. So I'm going to write a 4 on 2 of the sides of my square, like that. Okay, because remember, A squared means A times A. So I've now got a 4 and a 4, which I can times, and that means squared. So that's how I'm going to set that one out. And then my B is 3. So I'm going to put a 3 and a 3. And look, I don't know anything about this square, do I? It doesn't have a number with it. So there's nothing I can do with this square at the minute. Right, let's have a look then. Let's try and fill in these squares. So in order to fill in this box, I'm going to do 4 times 4. 4 squared, which is 16. So that in order to get that, I did 4 times 4. Right, in order to get what goes in this box, I'm going to do 3 times 3, which is 9. Right, now look at the boxes. The boxes, I'm just going to say that this box, add this box, equals this box. So I've got 16 plus 9 equals, well, 16 add 9 is 25. So I know that C's square has 25 in it. I need to work out what number goes on the outside of this square. So I did 4 times 4 to give me 16, and I did 3 times 3 to give me 9. So I need to think, what number, when I times it by itself, gives me 25? Now you might remember, you might know that 5 times 5 is 25. Or, if it's not a square number, if your answer is not going to be nice, sometimes we might need to use the calculator to do this last step. Okay, so just have a look here. I had 25, and I want to know what goes on the side of this square. So I'm going to do what we call the square root of 25. So on your calculator, you have a square root button. If on your scientific calculator, it's here. So you press square root of 25, and that tells you that it's 5. So it's 5 that goes on the outside of your square. If it wasn't a square number like 26, when you press equals, you might find that you get a square root in your answer. Remember, that's when we press that SD button. That turns it into a decimal. So some of these are going to be nasty decimals. Some of them are going to be nice numbers. Okay, you can use a calculator for all of this work. So our job was to find out what C is. Well, look, C is this number or this number. It doesn't matter. So C, we've worked out, is 5. Let's look at another one of them. Okay, so let's have another look. Can I fit it on? Can I fit it on here? I think possibly can. Let's do another one. Let's do one that isn't going to be nice. We'll have to use our calculator for this one. So I'm just drawing a random triangle. I haven't counted this one at all. So I'm going to say that this is 5 and this is 7. And I want to know what that one is. So as always, let's label it. C goes opposite the right angle. And then I've got A and B. Go there and there. Okay, so let's have a go. We're always going to write A squared plus B squared equals C squared. That shows the person that's looking at your work that you understand that this is a Pythagoras question, you've learnt the formula, and that in some mark schemes will get you a mark. So always, always, always worth writing that. And now let's draw our squares underneath. It doesn't matter how big these squares are, these are just to help us to be able to do the work. Plus, and then I need a square for B. I think it's worth doing the C square a little bit bigger, just to remind you that C is the big length, C is the hypotenuse, like that. Okay, so this is my square for A. Well, where's A? Here's A. So let's put my A onto here. So I've got 5, and then because I'm squaring it, I'm going to do 5 times 5. So that's my A square filled in. My B square, well, I've got 7, so I'm going to put a 7 and a 7. And then I'm going to leave it, and I'm going to fill that one in a second. So, A squared, well, A is 5, so I'm doing 5 times 5, which is 25. And then I've got my B, so I'm doing 7 times 7, which is 49. And I don't know anything about C at the minute, that's what I'm trying to find. Right, so look now, I need to work out what goes in this big square. So I'm adding my 25 and my 49, that gives me 74. So that goes in that big square. And then, in order to get what goes on the edge, remember that I type in square root of 74, 8.6. So that tells me that 8.6 goes on the edge. And you'd probably write down in your exam that you did the square root of 74, and that's given us 8.6. Okay, so I just rounded it. It was a long decimal, but I've rounded it to 1 decimal place. So then we can write that C equals 8.6. Okay, now this will be, she says confidently, on your GCSE. I don't think I've ever seen a year go by where Pythagoras hasn't popped up. Okay, so it's definitely worth knowing. So I'd like you to have a go now at worksheet 1. Now it's on worksheet 1, you'll always be trying to find C. I want you also this week to watch the second video and have a go at the second worksheet, which tells you how we find A and B. And it's exactly the same. But for now, we're just going to be looking at finding C. Okay, so I'd like you to stop, or this video will stop now, and I'd like you to have a go at worksheet 1, but remember that there is also another video, it's only a short video, to help you with the second worksheet this week. They're not long worksheets, just a couple of questions. Okay, read on Show My Homework exactly what I would like you to submit as well. Okay, keep the good work coming in, you're doing really well. And as always, if you get stuck, please let me know.